Give me a second. Hi everyone, welcome to the GATE 2024 session number 4. The first session was introduction. Second somehow was little bit of a what do you call trying to figure out what to do. The third one was obviously on the engineering. No, prior to that, I think we had done something on the linear algebra. Second one, third one we focused on moving from living linear algebra to a little bit more depth by looking at the question paper and answering. And this session we are going to continue. We did initiate permutation, combination, probability, but we want to go through the exercises. And later on, if Nikhil joins, Nikhil More, we will be the lead who is missing today. He should join us soon. We'll be able to continue on the what we call digital logic, which we are planning. Okay. With that, I will hand over to Jaimit Vasava, who is working on the permutation, combination, and probability. Go ahead, Jaimit, take over.
Yes.
Floor is yours. Thank you. Explain everything. Thanks.
Yeah. So, welcome to the GATE Study Circle, GATE 2025. Today we'll be discussing about permutation and combination. So these are some of the topics that are important from the aspect of math section of the paper. So permutation and combinations will be using the Byju's website for understanding the basics of permutation and combinations. They do vary in the core way of ordering and not being ordered. So permutation, it relates to act of arranging all the members of a set into some sequence or order. So order matters in permutation, whereas in combination, it's a way of selecting the items from a collection such that the order of the selection does not matter. So in permutation, order matters. In combination, order does not matter. So there are certain formulas for the permutation formula and the combination formula. Now these are the basic formulas, and on top of that, there are different different terms can be added based on the conditions provided from the question. But right now we'll be only focusing on permutation and combination formula. So permutation is one way of writing permutation from the total number of choices and the selected number of choices is this NPR. So the permutation's formula is n factorial divided by n minus r whole factorial. And same goes for the formula of the combination. It can be read as n choose r. So combination. So one way you can say is that this is the relation between the combination and the permutation. So combination formula is equals to the combination formula is equals to the permutation, which is NPR divided by r factorial, and then we simply substitute the formula of permutation. So n factorial divided by r factorial into n minus r factorial. Now, going through the differences between the permutation and combination, what is permutation used for? So arranging people, digits, number, alphabet, letters, and colors. Combination, selection of menu, food, clothes, subjects, team, etc. Then picking a team captain, pictures, and shortstop from a group. Whereas in combination, picking 3 team members from a group. For permutation, picking 2 favorite colors from a color brochure. For combination, picking two colors from a color brochure, any two colors. For permutation, because the repetition is not allowed, so picking first, second, and third winners. So all the things that permutation points over here in the table denotes is that you are not allowed repetitions, and that's why all of them are the unique values. Whereas in combination, it's uh, without repetition, but it's a choice for anything, and the order does not matter. So picking any three
One second.
winners.
One
Yes.
second. Uh, so in combination, if I give example, a 9 digit number, right?
Yes.
Say 10 digit number, 0 to 9. There are 10 digits. And let's say we want all 2 digit numbers, right?
Yes.
So if it is a combination, you don't care about the order.
Yeah.
So that means what? Whether it is 1991, both are same. Both are different. Sorry, because the order does matter in permutation.
Yes.
So that means if you have got, you will get, in this case, if you have 10 digits and 2 to be the, we want a permutation of 2 digit numbers that are all possible digits, 2 digit numbers that are possible from 0 to 9. That means out of 10 you need 2 digits. So that will be described as what? NPR, and N is here 10. R,
Yes.
R is 2.
Two.
So it will be n factorial divided by n minus r factorial. That is 10 factorial divided by 10 minus 2, which is 8 factorial. So 10
Yes.
factorial cancel out, you get 10 into 9, 90. So
Yes.
order, right? Whatever the order it may be, you have to permit that. Whether it is 19 or
Yeah.
91, you got 90 90 permutation, possible permutations here. But for the same thing, if you are asked what is the combination in that, then what will happen? It will be 90 divided by r factorial. In this case, r is 2. 2 factorial is 2. So only 45 combinations. Because 19 and 91 are same combination.
Yeah.
19 and 91 are different combination. Uh, Basically different selection. That means different selection is in here the order, you are worrying about the order being you don't care whether it is 19 or 91, but
Yeah.
you care that they are different order. So therefore the order does matter in case of permutation, and order does not matter in case of combination. I think
Yes.
that is very, you have to be a little bit cautious when you say selection. So okay, combination is more to deal with selection, permutation is to deal with ordering. So
Yeah.
1991 order. So permutation stick to talk about ordering. You are allowed all ordering. Repetition is allowed. Replacement is allowed, right?
So right now, the permutation and combination that we are discussing is without repetition.
One
So
second.
the
What repetition without repetition? Replacement. You go back and look at the top again. Read the definition. Permutation is the choice of things from set of things without replacement, and when the order matters. So you are not replacing anything, you are just order. If the order is there, it matters. 19 is 19, 91 is 91. Whereas in the other one, combination, the choice of the things, a set of things and without replacement, and where order does not matter. That means you select something, but out of that 1991 don't differ in that case for a 2 digit number. It considers that combination as a single thing. Whereas in the
oh,
permutation, it says that from a set of things without replacement. Now, what is the meaning of replacement in this case? Both are saying without the replacement. So without replacement is okay for both of them, but ordering is one area and not ordering, not worried about ordering is the other. So replacement, what do you mean by replacement?
So
You have a set, right? At the end of the day, you have a set. Set is 0 to 9.
yes,
0 to 9. That is a set. Now you are saying that you don't replace anything in the set, right? That is okay. You are not replacing anything. You are only making a ordered combination orders of two or two digits. Two digits you are taking. You are not replacing anything. So I can have 1 1 also. I can have 2 2 also, right?
yeah,
There is no. So it doesn't matter. 1 1 2 2 1 3 1 5, any of the two digits you can pick up in the permutation. In combination, it's not so, right? If I pick 1 and you pick 9 and again 9 and 1, no, that's not allowed. So that means replacement, what it means, a permutation is the choice of R things from N things. So R is in this case 2 digits out of 10 digits. Without replacement, you are not replacing anything. You are just keeping the same set. You are not changing. That means set is invariable. In the second one also, set is invariable, right? So
yeah,
that means out this set which you are using is constant. It's not replaced by some other set. But at the same time, orders do matter. They count in permutation. Order does not matter in combination. And that's why make sure that when you say their replacement is nothing to do. Forget about the replacement. Only thing is set. You have a set. And out of the set, you have within the set you have to select some, you are taking some number or some value in the sets which you want to define to do something. So make sure that you do not confuse replacement with ordering. Ordering, not order is valid. 9 1 is valid, 1 9 is valid. So I hope you don't
yeah,
mix, because otherwise you give the impression as if this is a replacement and that is replacement. Forget about replacement. You got a set. Permutation combination deals with a set. You have a set, and out of the set you are combining. When you are combining in an order, the order does matter, then it's a permutation. If you are combining but order does not matter, then it is permutation. Then it is a combination. So this is a clear. So you always look upon R. R is the key. R makes
yeah,
all the n. Yes, it does, but n is anyway factorial and n minus r factorial, that is common everywhere. It's the R factorial at the bottom, and you can call it as NPR and NCR. Easiest term is NPR and CR. Instead of all this into parentheses n and r, those are not the terms used. Mainly mathematicians say NPR or NCR. That's it. How they write is different. Okay, go ahead.
yeah,
Yeah. So where were we? We are on the problem. Yeah,
yeah,
comparisons are too
yeah.
really confusing, because you read one first and then second separate, not this one and that one and this one and that one. That messes up the whole thing. You for permutation, these are the examples. For combination, these are the examples. Don't compare the two. If you get
Okay.
compared, it gets into confusion as what are we talking here? Yeah, continue.
Yeah. So the difference between the permutation and the combination. For the permutations, the arranging of people digits, or picking a team captain, or other different additional roles for a team, or picking two favorite colors in order from a color brochure, or picking different uh, places for a competition for first, second, and third. These are the permutation examples where the order matters. In the combination, we select, but the order does not matter. So selection of menu, food, clothes, subjects, team, then picking 3 team members from a group, picking 2 colors from a color brochure, and picking 3 winners. These are the examples, and basically also the difference for the permutation and combination both when compared. So uses of permutation and combination is used for list of data where the order of the data matters, and the combination is used for a group of data where the order of the data doesn't matter. Now, if you have gone through the formulas for we have gone through the formulas for the permutation and combination, we can start to having a look at the examples for permutation and combination. So this is a very simple example just to get a gist of the permutation and combination. We have the n equals to 12 to find the number of permutations and combinations for the value of n equals to 12 and r equals to 2. So uh, according to the formula of permutation, it's n factorial divided by n minus r factorial. So uh, for substituting the values of n and r, we get 10 factorial by 8 factorial, and in the end, the value of 90.
One sec.
Sorry, I got it wrong. For
12.
permutation, sorry.
Yeah, go ahead. 12 and 12 factorial by.
Yeah, 12 factorial divided by 10 factorial.
So you
So our so in the end, it would be
12
12
into.
into 11, and the product would be 132.
So 12 into 11 is how much?
132.
132, and divide by
Yeah.
factorial is. So go down, see the answer.
Uh, okay.
Go down, show the answer, no? Yeah, how does it?
I thought it would be solving, so that's why I didn't
No,
show
no,
the.
you're solved already, right? You're solved.
Yeah.
So what you have done is you have said
Okay.
12 into 11 into 10, right?
Yeah.
Why is it taking 10? 12 minus 2 is
It would be 10 n minus
11 into 10. 11 into 10, so it
yeah,
is.
so 10 factorial get cancels and
Uh, and okay, divided by the 10. So 10 gets cancelled. 12 into 11, divided by
yeah.
2. 2 factorial, so it is 66. So 132 divided by 2 is 66. So we had taken for earlier for 10 digits, right? And that was 10 to 2 and not 12 to 2, right?
Yes.
Okay. So be careful and what numbers
Yeah.
of n and r.
Yeah.
Important to remember n and r the key. You can forget about rest of the world. This permutation is going to be all combinations. In fact, I think if you have something like r raised to n, I think. What are the n raised to r raised to n? I don't know. Something is there, another formula I forgot. Anyway, keep continuing.
Okay. So going for the combination of the same example one, we substitute the values of combination in the formula of n factorial divided by r factorial into n minus r factorial. We have 12 factorial divided by 2 factorial into 10 factorial. The 10 cancels up, gets cancelled out again, similar to the permutation. And so basically it's a 132 divided by 2 factorial. When we get the result, it's 66. So 132 divided by 2 is 66. So there are 66 combinations.
Next one,
Moving
example.
to the moving to the second example. Uh, in a dictionary, if all the permutation of letters of the word again are arranged in an order, what is the 49th word? So first, our n value here is 5, as again contains 5 alphabets. In that, A appears 2 times. So that if we want to calculate the total number of, sorry, we do not need to calculate the total right now.
Of
So
permutation, right?
yes,
Permutation allows repeats, right?
yes.
Okay.
So for for first we have to arrange the um, word again in alphabetical order. So it becomes double A G I N, and then when we calculate the permutation for single letters, we have for A we calculate 4 factorial divided by 1 factorial, 4 factorial out of 5, because we are calculating for A, and then uh, uh, the first A is there, so that's why 1 factorial, which will be equal to 24. Then when we calculate for G, it will be 4 factorial divided by 2 factorial, resulting into 12. And for I, it would be the same kind of calculation, but for I, so 4 factorial divided by 2 factorial equating to 12. Now we have the total 24 plus 12, 36, and 36 plus 12, 48. What we have to find is the 49th word. So the 49th word will be starting with N, because we have calculated for A, G, I. So it will be starting with N. And if alphabetically, if we arrange, it will be N as the starting letter and double A, G, I. So that's why the 49th word that we want is Nagi.
I'm confused with this one. Okay. I could not make out. What was it asked?
So it was asked that what would be the 49th word. If,
Of what? In a
so when we calculate the,
in a dictionary,
sorry,
in a dictionary,
yes,
if all permutation of the letters of the word again are arranged in an order, right? So you want in order A to N, or whatever A whatever uh,
yes,
G I N. So if you want in an ordered way, so you know the first is A, right? And then followed by G and followed by I and last one is N.
yes,
So now why that Nagi has come? You do AAGI, right?
yes,
For A you have calculated that it is 4 factorial. The arrange to the arranging the other 4 letters after A, correct?
yes,
The first one is A. So you in the letter in the short with starting with A, then you got GAIN. So you got 4. So the
yes,
because you are saying R, so that means you are taking 4 factorial.
yes.
Uh, it's a permutation. How do you arrive at 4 factorial? After 1, only 4 are there.
Uh, because we are calculating for the individual letter of A, starting with the individual letter of A and only calculating for A. So it would be 4 factorial, as the other rest of the alphabets are 4, and then divided by 1 factorial.
So
But for the other letters, if we move
start
from other anything other than A, Sorry.
No, start letter is there. Now total, he's talking about what is the 49th word. Where did 49 come in here?
So, so there are 24. This is the answer 24. So,
Why, why,
first letter,
why is it 24? You start with A, right?
yes,
So he's talking of first 24 words. Why is he talking of first
starting
20?
with A.
Yeah. So are we not talking of 49th word? Why not 48?
Yeah, but we have arranged the letter again in alphabetical order. After that, uh, for A, we got 24 letters. After arranging, starting with A, we got 24 words for A, starting with A, 12 words starting with G. So 24 plus 12, 36. And then when we calculated for I again, we got 12. So uh, 36 plus 12, 48. The question was asked for 49th word. And as we have calculated for all A, G, and I, so now the alphabet remains is N. So the first letter will be N, but in we are talking about alphabetical order. So that's why double A, G, I.
I'm still not clear on this. What do they mean by giving the when you say dictionary, if all permutation of the letters of the word A, J, I, N are arranged on the order, first is what is all permutation? So is the permutation coming out to 49?
No, if we calculate the total permutations, and then the total permutations are 120. So how we get 120 is there are total 5 letters. So 5 factorial upon, and there are two A's. So 2 factorial into 1 factorial for the other 3 letters which are appearing once. So just a second, is there any sketch?
So our definition of permutation was what? N factorial upon n minus r factorial, right? So it is n is 5 and n minus r is how many you are taking?
So this is
You are
the
taking,
total.
yeah.
So it's a total numbers will be calculated by n factorial, and our word is again. If we arrange in alphabetical order, double A.
My question was the formula does not seem to match here because our total
No,
is
no. This is for the total permutations. So the total number of letters. So we have 5,
Mhm.
and out of that, A are appearing twice. So 2 factorial for that, then 1 factorial for every other letter.
Okay. What does it give?
So if
First thing,
we,
top should be 5 factorial, right?
sorry,
Top should be 5 factorial, right? 5 into 4 into 3 into 5 fours are 20.
yes, yes, yeah, it's a 5 factorial.
So first is top is 5 factorial and then out of
So
5
it's
factorial, then now you are saying that at the bottom what should it be?
so it's
5 minus how much? 4 or 3? How?
so two gets cancelled basically
Not
with
like that.
2.
2 is not the issue. 5 minus r. What is r? N is 5. What is r?
But this is for the total factorial. This is we are not calculating the alpha the
We are calculating the permutation, right?
Yes, but this for a
One sec, n factorial upon n minus r factorial. So n means 5 minus what? 5 minus r is equal to 4 or r is equal to 5. If r is equal to 4, then it will be 24, right? 5 minus 4 will be, so you are getting already, what is it you are doing? See, you are saying that 5 factorial is equal to 5 into 4 into 3 into 2 into 1. That is 120, correct?
sorry, it's yeah. So
So 5
it
minus
will
4
be
will be what?
equating to sorry.
Yeah, go ahead. Now, what is this? I still don't understand how they have come up with this. First 24, yeah. So, why did you say 2 factorial? Because you are talking for A, or is it for only?
No, it's because of A is appearing in word again 2 times.
So, okay, and the rest of them are appearing what? One time? But then 5 factorial by what?
One time.
One sec. 5 factorial. It is not 60. It is not. Why does it come to 60? 5 minus what?
No, no. We
All permitted. Forget about all that. 5 by 5 factorial divided by 5 minus what?
th- this is for total, so that's why it won't be applying the
One sec.
permutation for NPR. Sorry,
What do you mean by total? Why is it total? We are taking permutation.
just a second.
We are taking permutation. Permutation definition is n factorial divided by n minus r factorial. So n minus r means what? What is r in this case? You are choosing one at a time or two at a time?
Uh,
We are permuting, right? We are not combining. We are permuting. It has to be correct. Okay, you cannot. If you are using a formula, either the formula is wrong or we are wrong. So, let's take it this way. Okay, even if you have, why is it come to 48? That means there is more you can do permutation. 48 permutations are allowed. That means
no.
then how
So the question is asked for 49th word.
no, but how does he? Okay, he can ask for 49 good. I have no problem. If a
Yes,
dictionary, if all permutation of the letters of the word
yes,
again can have all combination, right? All permutation, all everything is possible, right? All repeats are allowed.
yes,
Only thing is order does matter, right? Order means AA and AA are same, I can understand. But still, there are two A's, so AA and AA can be um, done twice, right? AG, so AGAIN, that is first one A, second G, third A. You already sorted it out saying it is AAGIN, right? AAGIN. So your permutation already AAGIN is what you are calculating. And they are arranged in order. What is the 49th word? Now the question is, why is he asking 49th word? Where the accounts up to 48th word, the 49th word is Nagi. What is this? Word is what? Word is a combination of these 5 letters, right? So you can have again, you can have gain, you can gaina, you can have ajena, right? So you are
yes,
repeating 5. So 5 factorial divide by how much? Divide by 5 minus 4 factorial or 5 minus 5 factorial or 5 minus 1 factorial. So you have got 5 letters. That's not word. A word is a 5-letter word, right?
yes.
So word is of 5. So 5's P what? 5p5. If it is 5p5, then what happens? So then it becomes 5 factorial divided by 5 minus 5, 0 factorial, which is 1. So 5 factorial is 5 into 4, 20 into 3, 20 into 60 into 2, 120. So you can have 120 words, exactly 120 words. So what is the 49th word he is asking if you are going orderly?
Yes.
So that means 5-letter word, there are 120 possible if we go by assuming that everything is possible, because all orders are, you can have any, it doesn't, A1 and AA are ordered, so all are 120 is possible. So out of 120 possible, what is the 49th if you are going by order? So A will have how much? Question is A will have how much, because each, if you have 5 and each of them are going to have uh, what you call 24, then because each one of them, if they have 24, then 5 of them will have 120, correct? So now the question is, if A is there, he is taking it as 24, because there are, he's saying that he's starting arrange the order of 4 letters GAIN. So he's not, has he said anything other than that GAIN? No. He's saying I am taking 4 letters, and 4 letters I can switch around as much as I want, right?
Yes.
So that means he's saying now I get a 4 factorial, that is 4, 3, 12 into 24. So for 4 letters, the word of 5, I can get 24. With a letter A is the first letter is A, and then I am using again gain, and therefore again I am getting a 24. So because you have got A, G, I, N, whatever, right? So you are getting
Yes.
24, 24, 24, 24. So first one 24 is counting with A, but with
Yes.
E is counting 12. Why? Because first word is already occupied, right? First letter is already defined.
No, no.
Yeah. Then
So,
second one is taking
uh, so, so all the combinations that, sorry, all the permutations starting with A are 24.
correct. Okay.
Then
Single.
it's calculating for all the combinations starting with G, but after that, all the letters can be used. So
Oh, one sec, one sec.
it's
Why others cannot be used otherwise? Of A and G,
because we are again is arranged in order. So because of that, we are going A, G, I, N.
okay, A, G and I. So 24, 12, 12, and then N will have another 12. Let's say,
No,
let's not worry about the 49. Right now you worry about,
okay, yeah. Then N will have 12.
so 12, 12 threes are 36 plus 4, 40 plus 20, 60. So the total is not 120, total is 60.
Yeah,
Why total is 60? Because 5 factorial by
2 factorial.
uh, 5, 4, 3, 2, 1 divided by 4. If you divide 5 factorial by 4 factorial, then what will be left is 5 only. N factorial by n minus r factorial, right? Am I
But
wrong?
so to
So there is
so
something we are not getting right.
so that for
So
calculating the total
uh,
permutations, the formula is n factorial
uh,
divided by the letters involved. So we have a P1, let's say P1 for A
uh,
factorial, then comes P2 for G.
no, no, one second, one second. Why are you going? We are arranging, our total is 5, right? A word consists of 5 letters.
Yes,
And with this, how many we can produce is the question.
yes,
And so it is 5p what? 5p4, 5p5.
This is not the calculation for the permutation. This is a calculation for NPR, but total number of unique permutations that are there. So
Is he asking unique? Are he saying it can be anything? Is he asking unique? That's what. Unique is then. Anyway, so n factorial on divide by p factorial, p2 factorial, p3. So I don't know why this p1 factorial, p2 factorial, p3 factorial. So that means, see, n factorial divide by n minus r. So what is r? R is only one less. So or two less. The problem is not well defined or well understood either way. He's talking about 49th word. So there are words, right? And the total number of words according to him is 60. Because that is what he is taking. Otherwise, he won't be doing 24, 12, 12, and then again another 12. So when he brings in n, then all words starting with n will be ending. So all letters starting with A, there are two A's, therefore it is 24. And all with G is 12. All with I will be 12. All with n will be 12. So then total comes out 60. So that means he's calculating permutation based on 5p2 plus 5p1 plus 5p1 plus 5p1. Because if you take 5p1, then it is only, I am still not clear on this, how it is applying these formulas. That means permutation formula is not applicable. We have to just go by the permutation that are possible. So we have to start with A with this 4, B with this 4, G with this 12, C. So this is the number of words he is counting, right? On the right side is the number of words.
yes,
So that means in this case, all these formulas don't work. What I am saying is at least formulas don't apply directly. So you have
yeah,
to, for everything, A, what combinations are there? A, we can have Jane. So you can have one with four of them. So you can juggle that four, and the juggling four means four square, that means 4 raised to 2. Or 4 raised to 2 won't do. 4, 3, 2. So 4, 3, 2, 1. 4, 3 is 12 into 2, 24. So 4 factorial is what he is coming up with. When you have A block 4, 3, 2, if first is start with, instead of A you start with G, then you don't have A still, you can have A, I and N. So you got again 4. And then it is, why is it 4 factorial by 2 factorial? You're getting my point. I can understand the first one, 4 factorial means you have A, then you can have anything out of the 4, so 4, 3, 2, 24.
yes.
But the second one, why is it divided by 2 factorial? Start with G, why?
Because
Because 2A.
because A, or for all the other ones, A is appearing twice. Uh, So G, when we start with the letter G, the A's are appearing twice. So that's why we are dividing with 2 factorial.
Okay. And same with the other one also.
Yes,
Okay. So 24 plus 12 plus 12, 36, 48, it has come. The 49th is then starting with N.
yes,
And then AAGI will continue. So that is the word.
yes,
Oh,
yes.
I am telling you, these permutation problems are problematic. So you
Uh,
cannot really apply any formula there.
yeah,
You have to take one by one and read between the lines what the letter means, what the word means, and what this combination is. Oh, good. Okay. So when permutation comes, don't apply the formula. That's my, if you know it is related to permutation, don't apply formula, just calculate based on the logic.
Yeah.
I do not see any relation between NPR, that is for one single one. Probably you can only talk about N single one. So each one of them you are calculating NPR, NPR plus 1 plus NPR 2 plus NPR 3 plus NPR 4. Correct? And
Yeah.
R in this case is 1. In one case it is probably 2. Correct? 4.
Yeah.
If you say uh, 2, then in that case what happens? 2. If you take NPR as 2, then what happens? 5P2. 5P2 is 5 factorial divided by 5 minus 2 factorial, which is 3 factorial.
20.
20. So, but still it is showing 24, right? So I don't see the use of formula. See, I'm trying to argue that there has to be some logic in this, so it doesn't appear like your formula has any meaning here. So to me,
Yeah.
it
So
looks like r raised to n. R is what? R raised to n. If your repetition is allowed, it is r raised to n, I believe. So r, we are one digit, n 1 raised to 5, 2 raised to 5, no, and n is so I think the formulas, NPR formula is somewhat jigged. I don't understand that, it does not fit into these problems. Okay, anyway, but that means what? Don't use the formula for this one, NPR here. If it is a permutation, you better calculate logically. Yeah, go ahead. Third.
yeah.
It's a sad thing, but I do not know why this such is the combination. Such is the permutation. Yeah, go ahead. Third one.
So, okay. So, about so for this example that we were discussing, the 4 factorial, it's actually 4 factorial divided by 1 factorial for all these letters. So 1 factorial for G, 1 factorial for A, 1 factorial for I, and 1 factorial for N. But because it were equating to 1,
So
so
what?
that's why they are directly written as 4 factorial.
So
Now, going for the so if we do not go for solving this question, we as said over here, we can so that the permutations were uh, calculated using this formula. So if we use it for the word for, let's say,
5 words.
yeah, so if you want so for 5 words it's 60, but if we wanted to start with A,
5 words, how did it come 60? That is what I'm asking.
yeah, so and there are total 5 words, so sorry, 5 letters,
Huh?
so it's 5 factorial. Now A is appearing twice in again, so it's 2 factorial. This is the formula actually.
Okay.
So 2 factorial, 1 factorial for G, I, and N, 1 factorial for all of them individually. So when we equate this, the answer is 60.
So you are saying the formula is n factorial by p1 factorial, p2 factorial, p3 factorial, p4 factorial, all that.
Yes.
Okay.
Now, if we calculate for again A, so and start with A, because so we have 4 letters remaining, because we are, so it's 4 factorial. Now A is we are accounting for the other A, but it's still 1. The number of A's are 1, so it will be 1 factorial, and so will be for G, I, and N.
Okay.
So that's why they uh, went for 24.
Yeah. Okay. Correct. And for again for
So for for G, if we take, but now when we do it for G, it's 4 factorial, because there are 4 other letters other than G, but and there are 2 A's being accounted for.
okay. So
So
that
that's why we are eliminating the,
okay.
sorry, we are accounting for the two A's.
Yeah, I think you
So,
have explained very well. You have explained very well. This is
now, so that's why it will be 12. And because we are going in this order, in alphabetical order,
so the
for
formula
the
for
first four, sorry,
yeah, no, got it. Again, for again you go for n, then it will be a 4 factorial by 2 factorial. Again, it will be 12.
yes,
So you are getting 24 plus 12 plus 12, which is 48, and then one more is there. N is there, another 12.
yes,
So you'll have 24 plus
60,
12 plus 12 plus. So this could have even been done as 4 factorial. I don't know why 2, 4 factorial 1, 4 factorial 1, 4 factorial. So 12 into 5, 60 we could have done. Confusion is because A double, right? We could have
correct.
ignored it. That doesn't matter whether A is once or twice. It's 4 factorial for every word, every letter being starting.
Yes,
So 12, 12 into 5, 60. 4 threes are 12, 2s are 24 divided by 2 every time. Assuming A don't matter. So basically it is like 12 into 5. Anyway, that's okay. But the formula is not exactly what we learned. That is only for one. NPR is only one. And if it is only one, that means we are permutation, we are taking one at a time for 5P1, 5P1 plus 5P1 plus 5P1 or whatever. I don't know, whatever that uh, 5 factorial, I don't know. That calculation somehow is not. To me, it looks like you have to take one, fix one, do for four, fix one, do for four, fix one, do for four, fix one, do for four. Yeah. Anyway, what you explained
yeah,
is better, sounds better. I think 4 by 2, 4 by 2, 4 factorial by 2 factorial for three of them,
yeah.
and for one of them it is 4 factorial by 1 factorial. Therefore, yeah. Next.
So, moving to example 3, we have the question of selecting a committee for 5 men and 3 women out of the positions of 9 men and 12 women. So it's 9 choose 5 and 12 choose 3 for men and women respectively. 9 choose 5 for men, 12
9
choose 3 for women. So when we use the combination
five out of
formula,
9. It's not 9 choose 5. It's 5. 9C5 you can say. Choose. It's not choose. It's choosing 5 out of 9. It's the other way around.
okay. So I'll simply say NC5.
Yeah, it is a 9C5. That means 5 out of 9. 9C5 is 5 out of 9. And 12C3 is 3 out of 12. So 9C5 is 9 divided by 9 minus 5 factorial, right? That is 4. So that means you have to take 5, 6, 7, 8, 9, right?
Yeah.
9 into 8 into 9. 5, 4, 3, 2, 1 will go away on 1. 9 minus 5 is 4. Sorry, 4. 4 onwards, everything will be gone.
Five onwards. It's combination. So
5, 6, 7, 8, 9.
1 by r. So 5 factorial will be gone from both.
5 into 4, 20 into 3, 60. 60 into. Doesn't look like again coming out properly, man.
Just a
Oh,
second.
this is combination. Sorry.
Yeah, yeah,
Combination. This is not permission. Okay, correct. So you are going to have NC n factorial by n minus r factorial and divide by r factorial.
yes.
So R in this case is the 3, right? So we have to again, first
Yeah,
case it
for
is,
women it's 3, for men it's 5. So
yeah, so you can calculate 9 by 9 minus 5 will be 9 factorial divided by 9 is 4 factorial. So 4 factorial and another 5 factorial will be at the bottom. So 5 factorial into 4
No,
factorial.
no. For women, it will be 3 factorial into 9 factorial.
Yeah,
5
3
is for men.
5. So you can go to the whiteboard and calculate and show. Just
Yeah. So uh,
clear this out. Yeah.
I don't know. Well, okay.
Yeah. Yeah.
So for men, it's it's NC5.
9c5. So 9,
So
9 factorial
9 factorial
divided by
divided by the 5 factorial
5 factorial into
for R and
9
uh,
minus.
yeah, 9 minus 5, so 4 factorial.
So whatever this turns out to be, this is equal to, we have to calculate. So
So
you
5
can say
factorial will be, yeah.
5
So
and factorial, 9 factorial will give you with only 9 into
4,
3, 4, no, 4, 3, 2 1 you write down. That 4 factorial leave it as it is. 9, 9 factorial and 5 factorial. So you only have remaining 6, 7, 8, 9.
yeah,
9, 8, 7, 6. That's it. 7 and 6. And 6 you can cut out with this 3 into
3
2.
and 2.
And 4 you can take, divide that 2. So that means it will be
4.
18.
So it will be,
18 is 36, right?
yeah, 40, 126.
Uh, oh. So 7 is remaining. 6, 6 is gone. That remove the 2 at the top. There is not, that 2 is not required. 6 and 6 is gone. There is no 2 at the top. Second 2 you remove. That is not required.
This,
Yeah, that's not required. So you got 9 into 2 into 7. 18, 18 sevens are 126. That's correct. Yeah. Okay, so that is for the men.
yeah.
And for the women, what is it now?
Per women, it's 12,
3.
12C3.
Yeah. So
So it's 12 factorial
2,
divided by
uh 3
3
factorial,
and 9.
right? So now the question is 9 factorial means you can 9 and 12 you can remain make it as 12, 11, 10,
10.
12, 11, 10, and this is 9, right? So
Yeah.
9 is gone. Then divide by 3 into 2. So you can say 2 into, 3 into 6 and 2 you get there. So 2 into 11 into 10. So 11 into 10, 10 into 2,
220.
220, right? Yeah. So you are getting 220 and 126. Now what does he want out of that? Go to the answer and see what does he want.
So the total numbers will be the multiplication of both the for men's combination and the women's combination.
How many were committee constituting 5 members and 3 women chosen from this? Okay. So it is a combination of the two. Okay. So combination gets multiplied. Okay. So how much you get then? 220 into 126, that is equal to 27720 ways. Okay, good. So combination multiplies. Okay, that's interesting. Yeah. Okay, go. Is there any other question? Next question in this?
No, but if I want to practice, these
Okay.
are some of the one in the continuation of it.
So okay. So we do have. Can you put up the link on the chat window so that people can try it out? Yeah. So Yash, are you there?
Yes, sir.
Are you listening to all the arguments here?
Yes, sir.
It is good, if you don't argue, you don't win. You don't get the
Yeah,
correct. So even though we may fight, it's good to fight here than fight in the exam.
yeah. You're absolutely right, sir. I mean, you have to actually like get the logic right. So,
So how is happening? How are things happening with you on the data analytics? Did you get the book? Did you
yeah,
start
sir.
start
I
reading? Started reading? Good.
So I got the book. I went through it. So currently I'll just be completing the maths part. So that will be of I think linear algebra, probability, and I think one more is there.
Calculus.
Yeah, yeah. I guess calculus. So
Differentiation and integration will be there, so that's okay. So are you getting right now permutation, combination, and probability?
no, that is I'm yet to reach there. I'm right now just completing the linear algebra part.
So linear algebra, did you see the recording last time? What was done?
Yeah, sir. I was there last time we discussed about eigenvalues and all.
Correct. Okay. Good. Keep it up. That's what we want you to keep the pace, because if you don't keep the pace, it is very easy to lose. Once a week, at least, you are forced to look at it.
Yeah, yeah,
Okay.
but
Go ahead. Anything you wanted to say? Go ahead.
yeah, sir. So that's why I'm also joining this. So it's like that. I have learned about this in college. So it's like the common logic is there, but the main thing is that how can you apply it more effectively and in less time.
Correct. That's why you have to try out before you can really do it on paper and pencil and whatever this whiteboard is doing. That's what is important. Yeah, go ahead, Jamie. I think you can go to the next one, right?
This was it for the permutation and combination.
And what about the probability you're done already? No, it's still there.
No, probability is left.
The probability and then we'll wind up. 15 minutes probability should do, I think. Go ahead.
So I planned only for the permutation and combination for this.
Yeah, okay. Anyway,
Probability.
you put the probability link.
Okay.
Give it to me. I'll take it.
Okay.
Let me share the screen and then you stop sharing. I'm sharing the screen and I'm going to take the
Just a second. Let me just
problem.
open correctly.
Okay, let me start with this and then I'll switch to the share, which is this permutation combination definition. Now, can you see the share now probability?
Yeah.
Yes, sir.
Okay, so what is probability? It's a likelihood of certain thing happening, and that thing, whatever you're thinking of happening, basically either that events happening is either 0 or 1 or anywhere in between. So the range of possibility is a percentage. 15% chance this will happen, 20% chance, 100% it will happen, 0% it will happen, right? Or which is equal to not happen. So probability is a basically a measurement of a occurrence of a random event, and the value is expressed between 0 and 1. Now, if that is the case, you can always have a probability of, if you have a coin and you toss it, the possible events are head and tail. So that means what? If you throw a coin, it will come down and you get a head or a tail, not like Amitabh Bachchan movie where it will stand in between, right? So it will be either head or tail. That means it's 50% chance that it is head and 50% chance it is tail. So that is the occurrence of event with 50% probability for a head or a tail. If there were, suppose, a dice, and dice has got 6 faces, it's a cube, right? It has got 6 faces, and on the dice there is a 1, 2, 3, 4, 5, 6. So the probability that one will fall is 1 in 6, because it could be 1, 2, 3, 4, 5, 6. The set of possibilities of events occurring is 6. Therefore, if one of them occurs, it will be 1, 1, 6. So for a coin toss, it is 1, one or the other, that is 1 by 2. For a dice, throwing a dice one time, it is 1 of the 6. So 1/6 probability for each one of them. So the formula of probability is event happening, probability that an event E is the estimate that happens is number of favorable outcome versus the total outcome. So in a dice there are 6 total outcomes and favorable is only 1, so it is 1 by 6 probability. In a coin it is only head or tail, so 2 total number of outcomes and possibly favorable is only 1, so it is 1 by 2. Hopefully this describes probability. And now he is talking about some examples. There are 6 pillows in a bed. Okay, 3 are red, 2 are yellow, 1 is blue. What is the probability of picking a yellow one? Okay, so now what happens? Yellows are 2 and total is 6, right? So probability that it's yellow is 2 by 6, because 3 plus 2 plus 1, 6 total, 6 are there, 6 pillows. So total is 6 and favorable is 2, 2 by 6. So it is 1/3. So picking a yellow is 1/3. Again, there is a container full of colored bottles, red, blue, green, and orange. Some of these are picked out and displaced. Submit, Summit did this. Sumit did this 1,000 times and got the following results. So now the question is, some of these were picked out and displaced. What does it mean, displaced? That means they were put back. I assume it is put back only, displaced, unless they were thrown out. So anyway, let's see. Number of blue bottles picked is 300. Number of red bottles is 200. Number of green bottle is 450. Number of orange bottle is 50. So 300, 200, 500 plus 450, 950 plus 50,000, right? So total is 1,000. And so what is he asking? A, what is the probability that Sumit will pick a green bottle? So there are 1,000 bottles and green bottles are 450. So 450 by 1,000, that is 0.45, right? Simple. If there are 100 bottles in the container, how many of them are likely to be green? So what the question is, what is the green bottles number? Green bottles number is 450. Okay. So the 450 out of 1,000 are green. Therefore, 100 bottles, if it picks up, the chances are 0.45%. So 100 into 0.45 will be 45. So chances are he will get 45 green. Easy? Now probability tree. So what you got, a tree diagram is organize and visualize different possible outcomes, branches and ends of the 3 or 2 main positions. So this is branching one side and the other side. So example, head, tail, outcome, probability 0.5, 0.5. What is he trying to do with this tree diagram? I don't know. It's very common sense. Yeah. Each ends are containing the final outcome. So our outcome is both. This is okay. I don't think this. Now there are 3 major types of probability: theoretical probability, experimental probability, and axiomatic probability. Theoretical is based on just chances, something will happen. And in a coin it is 50%. That we know. That is theoretical. But actually, experiment, does it happen that way? It is based on the basis of the observation of an experiment. Experimental probability can be calculated based on the number of possible outcomes by total number of trials. So you do 100 trials and find out in that what is correct. If a coin is tossed 10 times and the head comes 6 times, then the experimental probability is 6 out of 10. That is 0.6. And not head is 3, tail is 3 by 5, 3 point. So this is not exactly theoretical. If you say theoretical, it will be what? Half and half, right? In experimental, it is not half and half. It may be 60-40 or 60-30. In this case, it is 60-30 because he's experimenting and saying that no, he's not 60-40, it is 3 by 5. Because he's saying he is taking 6 times he's got the results which is heads out of 10 times. So he's simplifying it R3 by 5. That is fine. That is equal to 0.6. So the probability he found is 0.6 and not 0.5. So experimental probability may differ from theoretical probability. Axiomatic probability. Axiomatic probability is a set of rules or axioms that are set which applies to all types. These axioms are set of Kolmogorov and as known as Kolmogorov's three axioms. With the axiomatic approach to probability, chances of occurrence or non-occurrence of the event can be quantified. The axiomatic probability lessons cover these concepts in detail in Kolmogorov's three rule axioms along with various, I don't know where is that Kolmogorov's rule. Anyway, that is conditional probability is the likelihood of one of the event or outcome occurred based on the occurrence of previous event. Okay. So it's a conditional probability they are talking about in that. So probability of event P is R by N. What is R? E can occur R ways out of total N probability. So it is R by N. And the probability that event will occur are known as its failure is expressed as probability E is R by N. So probability of not E is N minus R by N. So R is success probability. So N minus R is failure probability. N minus R by N, which is again 1 minus R by N. So basically saying that if probability of success of an event is R by N, then probability of failure is 1 minus R by N. They can call whatever E prime, E, whatever. Therefore, PE plus PE prime, that is probability of occurrence of event, non-occurrence of event equal to 1. Okay. What is the likelihood of an event? When the events have the same theoretical probability of happening, they are called equally likely events. The result of some sample spaces are called equally likely if all of them have the same probability of occurrence. So in a dice, it will be 1 by 6 for having coin being dice being flipped and you get die being 1 to 6, right? And what is the probability that you are getting 3 and 5? So 2 out of 6, right? Equally probable, therefore 2 out of this. If you have 2 dice, then what happens? Getting 1 and 2, 3 on a rolling of a dice, that is 3 out of 6. So that is half. So complex complementary. So one will occur, one will not occur. It will rain. So not rain means it is complementary. Either it rains or it does not rain, not both, right? So that's what. Then they are talking about if you win a lottery, either you win or you don't. That is 50-50. Independent event. That means they are independent. Your winning is one probability, not winning is another. So they are independent. Or they are dependent. If you win, you can't lose. Or if you win lottery, you cannot not win, right? So they are mutually exclusive events. Probability theory its root in century back and all that probability density function. Density function is really that is the expertise of um, Jamith, right? So what is probability for continuous
No.
random variables, right?
Yeah. So there are discrete and continuous ones, and further they can be. Uh,
So the difference between probability density function and probability mass function.
yeah.
Density function is for continuous random variables, and mass function is for discrete variables, right?
Yeah.
Okay. So that means what distribution is? It is like probability can range from certain to certain. So it's a we call it as normal curve, right? Normal or bell curve.
Yeah.
So
That's for normal distribution.
yeah, that is for normal distribution is for continuous random variable, right?
Yeah.
Gaussian function, Gaussian, normal, all these are same thing.
Okay.
When you say Gaussian probability and normal probability, they mean the same thing. They are meant for continuous variable and they are represented by a bell curve. They are also called as bell curve. And then sample space. So population is the total uh, all possible samples, and in that the sample space set of all possible outcomes to occur in any trial. So if you take a trial, and like tossing of a coin is a trial, and the space total space is h and t. Rolling of a dice space is 1 to 6, and the sample space is, it is the one of the possible results. So if you talk about deck of cards, 52 cards, 4 heart cards is a sample point. The queen of club is a sample point. That means what? Whatever output you are expecting, it is 1 or n or whatever. So if you are going to get ace, I have 52 cards, I want to know, I'll get a ace. Now, which ace, it doesn't matter, right? It is a heart or club or spade or whatever. So that is 4. So 4 out of 52, that is the sample. So experimental trial, okay, all that we have seen, experimental we have seen, event we have seen, outcome we have seen, uh, complementary we have seen, impossible, the event cannot happen. If event cannot happen, then the probability of it is 0. It is impossible to get both head and tail together, right? Of course not. So application of probability we have seen, it is in the card, it's a flipping of coin, throwing of dice, pulling a red ball out of the bucket, out of red and white ball, winning a lucky draw, and all these are major application of probability. It is used for risk assessment, modeling, various industries, weather forecasting, prediction, probability of team winning sports based on the players and strength of team. In the share market, this is used for getting the share prices, right? Chances of. So problems and solutions. There are many problems and solutions. I think this should suffice for us for the day. We already are coming to 29:30. So frequently asked probability questions of examples, formulation of probability, and in this case the probability A plus B. This is very important. What are the basic rules of probability? If A and B are two events, then probability A union B is equal to probability of A plus probability of B minus intersection. Probability A and B both, intersection of both, that should be subtracted. Same way, intersection of probability of two events A and B is equal to probability of B and probability of A depend, given the probability of B. So these are two important things you remember: union and intersection. In union you subtract, in intersection you multiply the probability. So if you are having a probability of B, you know, then probability of A given B is nothing but intersection. Okay, and A union B is probability of A or B, and remove all the common in between A and B, right? So this is the logic, and the other things are very simple, not much to worry about. So example, what are the sample space of two coins? If you have two coins, then it could be head, 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 tail, tail, head, tail, tail, right? So now you've got 4. So they can confuse the hell out of you by putting two dices together or two cards, decks, and they will complicate it. That is the job of the examiner, and you have to fix and done. So we are 12:31. We are past 1 minute, and hopefully, what do you call our next time, Yash? You are going to talk about something which you need to know. We will continue with the digital design because digital logic is applicable for computer science also, and or not that we
Okay.
hopefully this time, and there will be one time when we want you to do something from computer science.
Sure, sir. Sure, sir. I'll be ready and I'll let you know.
Yeah. So, but you should not be ready after February. Okay, it should be now.
Yeah, sir. Yeah, sir. Yeah, sir. Don't worry.
Okay.
I'll
Okay.
be prepared.
Yeah. Okay. We are done. I will